Hello and welcome everyone. So in this tutorial, we will explore two powerful classification methods: support vectors machine (SVM) and a neural network. We will implement both using a Python Scikit-learn libraries and evaluate their performance and compare the result. So first, let's import all the library that we need. We import Panda as a PD to manage our data, and from Scikit-learn model selections we'll get a train test split and to divide our data. For our model, we will import SVC, which stands for support vectors classifiers, and MLP classifier, which is our multiple layers perceptrons or neural network. Finally, from the sklearn metric, we will import the confusion metric, accuracy scores, and classification reports just to see how well the models performs. So next, we will create our data set. We will use a simple dictionary with two features, age and salary, and one target label called purchase. Purchase is a binary target, 1 mean yes and 0 mean no. And we will convert this dictionary into a Panda data frames and print it out. As you can see, we have 12 rows of the data. So now we need to define the features where we call which we call x, and our target which is called y. So x is age and salary, and y will be the purchase. So it is a crucial step in machine learning is to split our data into a training and test set. We will use train test split functions. We're setting test size 0.25, which means 25% of the data will be used for testing, and 75% will be for training. We also set a random state 42 to ensure we get the same split every time we run the code. Make sure our result is reproducible. Let's print x trend and test and x test set to see the data we will be working with it. It's time. So now it's time to build our first model. We will start with SVM classifier. We create like instant SVC, where we're setting the kernel to linears, and which means our model will try to find a straight line boundary to separate the classes. And c equal to 1.0 is like a regularizations parameters which control how strictly the model classifies every point. So now we train or fit model using our training data x trained and y trained. With the model training, let's make a predictions. On our x test data, we will print the true purchase value from our test set alongside with the predictions made by our SVM models. So let's evaluate this. So first we create a confusion matrix. The output array is 2 0 and 0 1. So tell us we have a true false negative and two true negative and 0 false positive, 0 false positive, and 1 true positive. Now next we will calculate the accuracy by comparing the true labels x test and our prediction y prediction SVM, and looks at that the SVM accuracy is 1.0, which means 100%. For more details look, so we will print the classifier report As you can see, the precisions recall and F1 scores are all the perfect 1.0 for the both classes, and this means our SVM models made no mistake on the small test set. So now let's implement a neural network classifier. We use a MLP classifier with setting hidden like a layer size to 5, and which means we create a like one hidden layer with the 5 neurons, and the activation is set to value and the solver is Adam. So which is efficient like optimizers. We will set a like max ether for 1,000 to give like a plenty of training iterations. Just like before, we feed the neural network to our training data. The model will like iteratively like adjust its internal weight and to learn the patterns. So now we make like predictions where we call y predict and one, and let's print the true labels against the first set of neural predictions. Let's check the accuracy for this model. So we get about like 0.66 or like 66.7%, not as good as SVM. Compare the prediction side by side. The SVM predicts A010 and it was correct, and the neural network predicts 000 and missing one. Let's try to improve like the neural network. We can adjust the parameter. Let's try again, and this time like 100 with 100 neuron in the hidden layer, and increasing the max ether for 2000. We will fit this new model so it make news predictions called y predict and 2, and let's check the accuracy. So the accuracy is dropped to 0.33 or 33.3%, and the second attempt was even worse. So the predictions the predictions were 111, and the report shows it completely failed to identify zero in this time. So what's the interpretations of this result? So the support vectors, a machine was very robust and performs perfectly even on the extreme small datasets. And the neural networks, like however, struggled. This demonstrate that a neural network often require much more data and careful like tuning for like produce optimal results. So in this case, it was not right tool for the job. To summarize, we import our like first step is import the libraries and the tool, and the second step is like create a suitable data set for the classification. Step 3 is define a feature X and target Y clearly, and step 4 is split data set into a training and a test subsets. Step 5 is train and evaluate SVM classifier. And step 6 is train and evaluate neural network as classifiers, and step 7 is compare the predictions between classifiers. So after watching this, you should now understand like the basic concept of the SVMs and the neural networks, know how to implement them in Scikit-learn, and be able to evaluate and interpret their performance using classifications reports. And thank you for your watchings. So if you found it's helpful, please don't forget to like, share, and subscribe. And see you in the next video. Goodbye.